Hi everybody. This video is going to be our fifth and last AP review video. And what I did here on the first page of the notes is I just typed up some antiderivative rules along with some of the processes that you use to find antiderivatives. I would really highly recommend kind of reviewing these rules on your own, looking through some of the example problems that I've included, and just make sure that you understand what it is that you're supposed to do when you find these antiderivatives. I'm only going to point out one thing that I think is worth kind of reviewing together, which is the idea that whenever your exponent is -1, that you're using a natural log, and that goes to whether it's just an x or an x minus 5, the power is still a -1 because it's in the denominator. And so I think it's really important to differentiate between when we use a natural logarithm versus when we're allowed to apply the power rule. So that is one thing that I would highly recommend that you go back and review before taking the AP test. The other thing I would highly recommend that you go back and review before taking the AP test is like some common mistakes that we often see. So one of the things is that when we see a problem like this and we ask you to find the antiderivative, students often forget that you need to divide by a -1 because of the fact that there's a negative by the x. The same thing with e to the -x, there's really a little invisible -1 by the x, and if you divide by that -1, you get -e to the -x. So some of these just common mistakes, easy things to make a mistake with. A common mistake that I often see whenever a problem says 1 over e to the x is that students want to say that the antiderivative would be the natural log of e to the x. But in reality, what you're going to want to do for a problem like this one is rewrite it as e to the -x, because if it's in the denominator, then the exponent is really a negative, and then apply the same rule that we're seeing here, where you divide by a negative. I'm not going to go through all of these rules. These are for you to review on your own. But what I do want to spend a few minutes going over is the idea of U substitution. So U substitution is really just a procedure to undo chain rule. And what I want to remind you is that most of the time, you really don't have to do a U substitution. So for kind of the time that we've been doing antiderivatives, we've always said you can kind of do it in your head, or you can do a U substitution to figure it out. There is really only one time on the AP test that I've ever seen where you have to do a U substitution. So most of the time, what we just talked about, where you kind of recognize that the chain rule would have happened with this little negative and then know to divide by the negative, that would be something that you could use a U substitution for. It's just you don't need to if you can recognize it without doing a U substitution. An example problem like this one is an example where you have to do a U substitution, so I thought it was worth going through the process one more time. For a U substitution, the first step is to choose your U. Now, your U should be the thing that causes the chain rule. So in this problem, what causes chain rule to be a consideration is the fact that inside of the square root, we have 2x plus 1. It's not just x. So our U would be 2x plus 1, because having the 2x plus 1 would have made us use the chain rule when we originally found the derivative, which now we're trying to undo. Then we would take the derivative. So du over dx equals 2. And again, this is because we're trying to identify the chain that should be there. So if this causes the chain rule, what should the chain be? Then we need to solve for dx. So we're going to multiply by the dx, and then I'm going to mentally divide by 2 at the same time, which means I get dx equals du over 2. Now this is all kind of prep work to do before you get started with your U substitution. After you've done that work, you're going to actually do the substitution. So we're going to have our integral. And the first thing I'm going to do is I'm going to change the bounds. My original bounds were 0 and 2. What I'm going to do is plug in the 0 and the 2 into this equation where I've identified for my u, and I'm going to change the 0 and the 2 into u values instead of x values. So if I plug in the 2, I get 5 for my new upper bound, and if I plug in the 0, I get 1 for my new lower bound. Now I'm going to have the square root, which is still there, but instead of the 2x plus 1, I'm going to replace that with u, because that's what I've decided to call it, and I'm going to replace the dx, which is right here, with what I've identified for dx here by solving, which would be du divided by 2. Now, I don't usually like to leave my answer like that. I usually like to take this dividing by 2 and rewrite it at the beginning. So my new integral would just be the integral from 1 to 5, and instead of writing it as dividing by 2, I'm going to put it as a 1/2, and then I'm going to have the square root of u du. Now from there, I can identify which one of these options would give me the same answer as the original problem, which would be option, it looks like option C is the correct answer here. Okay. Now, one of the other problems I wanted to go over were a couple of what I would consider a little bit of the trickier evaluating and integral questions from FRQs that we've seen on the AP test over the last few years. So in one of the AP test questions, we saw a table of values like this one, and it said evaluate this integral. Now, in order to do that, we need to find the antiderivative. So the antiderivative of the second derivative would be the first derivative. So I would say that the antiderivative is f prime of 2x. However, one thing that I need to recognize is that having the 2x here should have caused a chain to happen. The chain should have been multiplying by 2. Now, in order to undo that without using a u substitution, we just have to do the opposite. So we would just divide by 2, which means putting a 1/2 here. Then we need to evaluate this from 1 to 3. Now, showing this is a really key step of the problem. It shows whoever is grading this problem that you understand how an integral works in calculus. What I would do now is plug in the 3 first. So I would have 1/2 times f prime of, and if I plug in the number 3 first, I'm going to have f prime of 6. And minus 1/2 and then f prime of, and if I plug in the number 1 second, I would have 2. And in this problem, the table of values is where I'm going to actually be able to find these answers. So f prime of 6 from the table would be 5, which means I have 1/2 times 5 minus 1/2 times, and f prime of 2 would be -2, which means I would get 5 over 2 plus 1, which is 7 over 2. Now, as you guys are aware, the entire test this year is a calculator test because it's at home. And so I expect that if the AP test does require you to evaluate an integral, it's going to look something like this, because a calculator here really doesn't help you except for in the last step. We know that our calculators can find integrals for us. So if they just gave you a regular old find the integral problem, you would just be able to type it in. A problem like this one would be really great because, again, your calculator doesn't help you, and a problem like this one would be really great because other than arithmetic, your calculator doesn't help you. You're really required to have some calculus knowledge to get these answers. Let's do one more that's very similar. So it says evaluate this integral, which means the first thing we're going to need to do is the antiderivative. Now, in order to find the antiderivative here, here's what I need to recognize. Inside of this integral, we have f prime of g of x times g prime. This right here should remind you of chain rule. It's the derivative of the outside function, leave the inside alone, times the derivative of the inside function, which means the antiderivative would just be f of g of x. The original function would have just been f with g on the inside, because then applying chain rule, I would have taken the derivative of the outside, leave the inside alone, and then do the derivative of the inside. So that's kind of the key of this question, is realizing that all you're really doing here is going backwards from chain rule. Now we're going to evaluate that between -2 and 3. So once again, we're going to plug in the 3 first, which means we have f of g of 3 minus, and now we're going to plug in the -2 second. So we're going to have f of g of -2, which means my final answer here can be calculated using the values from this table. First, what I need to do is find g of 3. So in this table, I'm going to find the 3 as my x value, and I'm going to find g of 3, which is 1. So now what I need to calculate is f of 1 minus f of, now I need to find g of -2. So I'm going to find -2 as my x value, and I'm going to find g of -2, which is -1. As my next step, I'm going to find f of those values. So if I find f of 1 in this table, when x is 1, f of 1 is 2, minus, and if I find f of -1, when x is -1, f is 8, which means my final answer would just be -6. Again, I think this is a great type of AP question where, in spite of the fact that you have a calculator to use, it doesn't really help you to do this problem. So I think if the AP test decides to assess finding and evaluating integrals as part of this year's FRQs, it's likely to look more like this because your calculator doesn't really have the ability to help you with the concept of an antiderivative here. All right, thank you guys so much for watching. I hope that you find these notes helpful when you're taking your AP test, and have a great day.